Welcome all. My name is Vishal. I work for Billigence from the last. I've been working with them from the last 2.5 years, and today I'm going to present one of my very interesting and favorite topics. It's about spatial mapping in Tableau. Okay, let's get started with the webinar, and I'll be covering a wide range of topics. So yeah, looking forward to the session. Okay, first thing first, who we are. We are a consulting firm. We are across the globe, and we deliver tailor-made client solutions to various industries. And yeah. Okay, what do we do in specific? Some of our key capabilities are data visualization, predictive modeling, data governance, and obviously data consolidation. We also do some automated CRMs, and we specialize in a lot of these different dimensions, I would say. Whom do we work with? A variety of clients, starting from government, retail, finance, telco, education. We work with different industries and with different teams as well. Now, I'll go into the basics of this particular topic. Before we talk about spatial analytics or mapping, there are some very basic common elements that I would like to take through in this first slide. Okay, first thing first, we speak about latitude, longitudes, and addresses whenever we are referring to maps or spatial analytics. So what is latitude and longitude? Okay, it's basically a coordinate system by means of which where you're locating place or a point on the surface of Earth. So basically, any particular address, you would normally expect it to have a latitude and longitude as well. Okay, deep dive into this analytics, spatial analytics conversation, we speak about points. So what are points? Points are basically the same thing that you're referring to as an address. So again, a point will always have a latitude and longitude, and a point can be anywhere on the Earth. It can be in Sydney, it can be in North Sydney. It will be usually a specific point, I would say. Okay, moving on to the next one. Okay, we will speak about these points, lines, and polygons. So the next one is line. So what is a line? Basically, it can be point A to point B. Okay, it's a collection of individual points, addresses. It doesn't necessarily have to be like this as displayed on the presentation. It can be, 3 points connected by a line. Following by the most important thing is called a polygon. So a polygon is a set of different shapes that represent a geographic location. In this webinar, we will be going through some of these polygons in detail. For instance, SA1, SA2, SA3, and they're pretty much I would say a set of area. For instance, local government area. We speak about Hillshire. We speak about Sutherlandshire. So basically, a group of addresses, basically suburbs or postcodes that are being defined into a polygon in this particular instance. Okay, what will we cover today? We are covering a wide range of topics, but at the same time, I'll be demonstrating some of the real life use cases that we normally use in day-to-day lives. Okay, the first and foremost thing is, we're talking about spatial data. Okay, what is it? How is it stored? Is the first question that would come into mind. There are a number of ways that the spatial data can be stored. Some of them can be KML, some of them can be GeoJSON, but in this particular instance, to make it a simple, and an effective presentation, I have taken spatial files into Tableau. Okay. And what are the use cases? I'm going to show you how to load an SA3 file into Tableau, a road segment file, and obviously connecting to even BigQuery. And how do you make a connection BigQuery and ensure that latitudes and longitudes are recognized? So I'll be running through some of the basic settings that you would normally have to look into. The next one is very interesting, performing a spatial join. I will be creating a dual access map with SA3 and points. So, it's going to be quite a good session, I would say. The next one is create a buffer. Okay, so what is a buffer? So we have points, and let's say you want to create a 5-kilometer radius around a point. That's what we call a buffer in Tableau, and I will demonstrate how we can do that. The next one is finding the distance between 2 points. So usually in retail, it's very important for them to analyze, how much do I have to travel for the next store? What's the distance between a distribution center and the store? So those sort of things are predominantly used in retail, and we would like to show in Tableau how can you do that. And the last one is creating a line between these 2 points. There's a concept called origin and destination maps in Tableau, or essentially they call it as spider maps. And we would like to demonstrate, how do you build that and where would you use it? Okay, let's get started. Okay, how do you load a shapefile in Tableau? Usually Tableau desktop lets us drag and drop file into the Tableau 2020. And sorry, the version that we're going to use is 2020.3. So some of the features that I will be demonstrating are specific to that particular version and the ones up after that. Okay, so Tableau lets us actually drag and drop files such as CSV, such as XLSX, that allows us to perform analysis. Similarly, with shape files, you can also drag and drop the specific files. Okay, in this particular, alternatively, you can also select a window on Tableau which says a spatial file, and then once you click on it, you'll be able to use it. And what does a shapefile contain? So these are the 5 different elements a shapefile would contain. But what you should be looking after is a .shp extension. I'll demonstrate now how to do that. Okay, so this is my Tableau desktop, and I'm using a 2020.3 version. And okay, if I click on new data source, I'll have few options enabled here. So I'm going to select the spatial file. And obviously, you can see by default, Tableau is actually showing you, OK, this is the file that we can read out of those 5 files. So what I'm going to do now is I'm going to click that and then click open. OK. So as a best practice, we normally use extracts. And part of the reason why we should use extract is for better performance. And I'm going to click save, and I'm going to click yes. OK, here we go. Oh, we've got a shape file now loaded into Tableau. If you notice here, you don't see any. Well, actually, you can see geometry and latitude and longitude. OK, I'm going to click on I'm going to click on geometry, and let's see what it happens. OK. Oh, wow. That's as simple as it for you to load a shapefile in Tableau. So what are these? These are SA3 polygons that government actually creates this for us. What it means is if you're living in, let's say, somewhere in Sydney, then you actually fall under this particular service area or region. To know what are them, you can just drag and drop them into the detail, and let's say we'll hover on it and we'll just see, what is this? Okay. This is called this SA4. Okay, it's Sydney, North Sydney, and Hornsby, and Sydney right. And okay, there's another SA3 one. Let's see, what does it show? Okay, so this particular SA3 is Ku-ring-gai, and SA4 for it is Sydney, North Sydney, and Hornsby. Okay. Cool. That's one use case of pulling a shapefile with SA3 boundaries into Tableau, and obviously you can see a lot of different information there. So I'm going to go ahead and pull a slightly different file. Okay, again a shapefile, but what it demonstrates is a set of lines. Okay, so what I've done is, so this is the road segment file. So what it contains is a list of all the roads, pretty much, I would say most of them in specific area of Sydney, but I wouldn't say entirely. And let's see, how does it represent information? Okay. It might be a slightly bigger file because it has all the different roads. Let's give itself, a few seconds for it to load. Okay. That's not bad actually. 15 seconds for it. Okay, what am I looking for again? I'm going to double click on geometry, and then I'm just going to see. Oh wow, okay, that's a lot of roads. Okay, but okay, you see in the map behind. Okay, it's not so really neat and eligible. Is there any way to change that? Yes. So on the map menu button here, you can actually select, what sort of background would you like to choose. For instance, I've selected a light background, and it doesn't look very, neat and clean. So I'm going to select different options and then see, how does it look. Okay, yeah, slightly better, I would say. Can we have slightly better one? Yeah, that goes with dark. Then that goes with. Okay, yeah, I think I probably like this much better. So what am I going to do? I'm going to zoom a little bit and then possibly around Sydney, I would say. Yeah, or maybe. Yeah. Okay. So what does it contain? This particular file doesn't have actually shapes, but it rather contains line. So necessarily when you are importing a shape file, it can be shapes or it can also be, a specific lines. Okay. Now I'm going to go ahead and then connect to BigQuery, a public data set in BigQuery, to show, it. Not every time necessarily you would need to deal with a shape file. Okay, there will be times where you'll deal with a simple latitude and longitude. Okay, I'm just going to select my first project, and I'm going to just select public data, and then I'm going to select samples. Okay. Yeah, that's my query where it has some weather stations. So it's basically a public data set that is available for us to actually perform some analysis. As you can see, it is not a shape file. It is basically flat table. It has latitude and longitude. I'm going to click extract, and then I'm going to show you, how do we actually see these, points in Tableau. Okay, there we go. So we have latitude and longitude, and you do notice that there's no geometry file there. So I'm going to double click on latitude and longitude. Oh, wow. It's just showing a single point. It is important for us to make sure you convert these into dimensions before you actually pull it. Okay, okay. So I'm going to now do the same thing. Oh, wow. That's a lot of circles and a lot of points. So I believe that's where the weather data is being captured, and we have like multiple IDs across. If I zoom to Australia, then we have a lot of points plotted over there. One of the key important thing is to make sure that the data type you select is always in a decimal, and obviously it's in a dimension, so that you are actually viewing that on top of Tableau. Okay. So that concludes the first segment, which is how to load shapefile into Tableau. Now we'll deep dive a little bit deeper into what we can do out of the shapefiles or these points that we're currently talking about. Okay, so we have just seen two examples. I would rather say three, but I'm going to just take two out of them, and then I'm going to demonstrate how do you create a dual axis map. So in the first instance, we saw SA3 polygons, and it's basically a shapefile that we have loaded on top of Tableau. The second one is Australia Global Historic Climate Network Stations, and we did see that we have the data that is representing the whole world, I would say. And let's aim for something quite big here. So let's say we want to achieve this particular map. Okay, what is this map? It's a dual axis map. It has two sets of geographic data overlaid on one top of each other. Essentially, we are talking about polygons and points. So we saw in the background we had polygons before, and now we're having points now. Okay, why would we use these sort of maps? Okay, I'll give you an example. Probably a year ago, when we all know COVID happened, and things were all over the place. And if you see in the news, government is actually providing COVID cases by LGA. So what is an LGA? Again, it's a government-defined polygon, which they say, okay, in North Sydney LGA, for example, there might be 10 COVID cases. So they're giving by a specific set of regions, saying, okay, these are the number of cases that we currently have. And let's say you work in a retail environment, and you have stores all over Australia, and you're keen to compare. Okay, is there any correlation between code cases in that specific NGA and how your sales are performing? It doesn't necessarily mean. It doesn't necessarily have to have a correlation, but these are the sort of analysis that usually retail environments prefer to do, so that they know, okay, what is happening around. In these particular cases, creating a dual axis map with a polygon and point will be absolutely helpful for them. Okay, now I'm going to demonstrate how do you create this map out of these two maps. Okay, I'm just going to close my other one so that it doesn't take too much space and memory. Okay, first thing first, I basically need to perform a spatial join. Okay, on the first hand, okay, I have my shapefile which is already created as an extract. Okay, I'm going to go ahead and recreate that connection to BigQuery. And by the way, BigQuery is actually free for a certain limit. So even you can actually go and access BigQuery with your own personal Gmail account and have some sort of information. Okay, so I'm just going to do a select star from my GHCND stations, and then I'm going to go ahead and create my second extract. Okay, I should have actually added my connection on top of that so that I can perform a spatial join. So I'm going to go ahead there and then click there. Okay, so now I need to perform a spatial join. You see in this initial shapefile, you see this geometry column there. Okay, I'm going to select that. What it contains is those shapes that we actually spoke about. And on the other side, okay, I don't have any geometry column. So how do I create one? Or I have to actually make a point. Okay. Before I go in there, I think I need to clarify a little bit on this particular formula that I'm applying. Okay, so I'm using a formula called make point. Okay, so what I'm doing is I'm inputting latitude and longitude, and I'm actually creating a point. It is basically the same as how you drag a latitude and longitude, but instead of dragging two separate fields, we are keeping them in a single field called make point. Okay, I'm going to click apply. And then I'm going to click OK. And you see here how there's a new feature called intersects. So I'm going to click intersects. So what it will do is it will. So this is my right table, and let's say this is my left table. My left table has all the Australian data in it. My right table has all the global data. So now in the map, I should expect it to see only the Australian data because I'm selecting an intersects feature. Okay. Boom, there you go. So we need to create a dual axis map which contains all the GH3 locations and the SA3 polygons. So what am I going to do now is I'm going to double click on geometry. Okay, so now in my spatial join file, I have all the different polygons. At the same time, I'm going to click on latitude and longitude. Okay, same issue. We have to go back to the basics and then convert it to a dimension for us to be able to view the numbers. Okay, if you recall previously, I've done a calculation which says make point. It's not visible here, and part of the reason why it's not visible is because it's a runtime calculation that I've done while doing the join. So I'm going to go ahead and recreate that, make point calculation, longitude. I'm just going to call this GHCN locations. Okay, so I can see there's a new calculation, and if you also look a little bit deeper there, it's actually similar to what's there in geometry. So I'm going to double click there. Oh wow, I'm seeing all the location of GHCN, climate networks. Okay, so now how do I create a dual axis map? Okay, I'm going to double click on geometry first, and then I'm going to drag the longitude and latitude onto the same window. You see how two maps are actually created. Okay, so I'm going to take this detail off, and then I'm going to slowly add in geometry in detail, and you can see one map would appear here. Okay, so you see how they're polygons, and then I'm going to drag and drop GHCN locations into the detail there. Oh, wow, I can essentially see some points. To differentiate these two, I'm just going to color them slightly in a different color so that it's actually visually, aesthetically, simple to understand. The next thing is I'm going to click on the dual axis map there. And again here, boom, there you go. So we are seeing SA3 regions, and obviously a complete different data set, BigQuery, and it has a climate networks, and we're seeing on top of each other. So let's say we need to know, okay, what does it mean now is the question that you might have. Okay, so sometimes we need to know in this specific SA3 how many stores are there, how many network locations are there. So how would I do that? I'm just going to go and create a new calculation. I'm going to call it as count distinct and ID. Okay, and ID is a unique identifier for each of these areas. So I'm going to go and drag it into the detail shelf. Okay. Okay, so in this Goldfield SA3, we have 188 stations. If we move that to Midwest SA3, then we have 462 stations. So these are some of the insights that usually business teams would be after. Okay, I'm going to go back to the presentation, and I'm going to continue with my the next details. We all know that COVID has thrown us some challenges. Okay. And some of the challenges around, in particular in Melbourne, there's a restriction around, you can't go 5 kilometers away from your home. Okay, so this is a similar use case. What we have is data from an ACT. Basically, so I think some of these are, emergency related, points, and what we could do is we could create a circle around this point to say, okay, we're traveling 4 kilometers away. And please do note that this is not the same as what you see in your, in your Google Maps. Usually Google Maps give you a road time radius and time, but what we are after here is more of an a time, radius and time, I would say. And okay, let's see how we can do this. So there's actually a calculation in Tableau. There's a thing called buffer, and there's a small syntax says, if you have a geometry column, and then if you select 4 kilometers, then it actually creates a 4 kilometer circle for you. Just keep in mind that 4 doesn't have to be 4. Like, you can actually give a parameter to let the user dynamically select how much radius they want to go. So 4 is something that I've given as an example, and now I'm going to demonstrate this how to do this in Tableau. Okay. Sorry, guys. Okay. I'm going to create a buffer. Okay, this is another shape file. it actually contains the National Emergency Services Facilities data. So I'm just going to drag and drop into my data window, and then I'm going to create an extract. Okay. I'm going to double click on geometry, and then I'm going to select map, and then streets, maybe streets. Yep. I'm going to make them into a bigger circle. No, actually, I can't. So yeah, the idea is we have different points around Canberra, and let's say I select a operational name. Okay, there's nothing in operational. Okay, cool. So let's take up the task to create a circle between around these points. So how am I going to do that? I'm going to create a calculated field, and let's say all these make points or a buffer, you wouldn't know how to do it. Then you can actually check for the syntax, and then if you click on buffer, you actually have an example to see how you can do it. Okay. I'm going to click on make, buffer. And then I'm going to select geometry. And then I'm going to, let's say, select 5. And then I'm going to need in kilometers. Oops, sorry. That's a number. And because I gave it as a string, it should pop up some error. I'm just going to call this calculation as create circle. And I'm going to click apply. Okay, I'm going to go to a new sheet, and then I'm going to click that. Okay, you see how there are circles now around the points that we have created, but it's actually not legitimate. So let's create a dual axis map for this again. I'm going to do the same principle that I've done previously. I'm going to drag and drop longitude and latitude onto the right, and then I'm going to create a dual axis. Sorry, yeah, I can create a dual axis like this. Then I'm going to pull that out, and then I'm going to put them back in. Does look quite a bit big, so I'm going to change them into a slightly different color. Okay, that's probably much need to read. It looks like 5 kilometers is a bit too much, so I'm going to change that to 2 kilometers now. Okay, the map looks much neater, I would say. Okay, so that's the idea around creating a circle around a point. Again, it's a dual axis map, and you can create using a simple buffer function. Cool. Let's get back into the presentation. Okay. The next point is about finding a distance between 2 points, and at the same time plotting those different points using a line is what we are trying to achieve. This activity is slightly a bit longer task, but I'll try and break down into multiple phases as I explain this. Okay, so let's say we have a data set with different points across Sydney. Okay, they could be a retail store, they could be basically anything, and let's assume like these black stars are the different stores. And let's say from a given point, let's say there's a store, you want to find the distance between different points across different stores. So you want to find the distance between A to B, A to C, A to D, A to E, A to F, like that, so on, like that. How can we do that? Is our next task. I'm gonna demonstrate that. So the dataset that I'm currently using is basically COVID-safe, New South Wales retail grocery stores. It's a public data set. If you just type in COVID-safe New South Wales retail groceries, then you would get a data set that is available for us. So just more for your FYI, there's a lot of public data with spatial content available on the data.gov.au website, or there's a plenty of data sets for you to explore as well. Okay, so we have this particular data ready. I'm going to create an extract. And then notice how there is latitude and longitude with different data types. So please make sure that you perform these checks when you're doing your analysis. You have to convert them into a decimal and then see how it automatically picked up the latitude, but for some reason it didn't pick up a longitude. So I'm going to go ahead to geographic role and then I'm going to select longitude. Okay. So let's assume these are the different stores that are currently there, and our task is to, let's say, find the distance between this and the remaining stores in this particular image. Okay, I'm going to go back, and what I'm going to do is create a relationship between the same table. The reason being for us to do that is Tableau by itself can't interpret this as an origin and this as a destination. So we have to create this particular stream where Tableau identifies this as an origin and this as a destination. For you to find a distance between on your Google map, you would say, okay, I live in Epping and I want to go to, let's say, Chatswood. You would try and find what's your source and what's the destination. Similarly, when you're trying to find a distance between 2 points, you have to structure the data in such a way that you are able to find the distance. So in order to do that, I'm going to create a relationship between the same sheets. For instance, sheet 1, which is what we have, and again the sheet 1. What I'm going to do is I'm going to create a relationship calculation. I'm just going to call it as 1. Okay, and I'm going to call it as 2. And then I'm going to select 1 is not equal to 2. What that will do is it will create a cross join between these two tables, and then it will multiply and give us the records. Okay, for some reason it doesn't let me do it. So okay, yeah. So sheet 1, again, sheet 11, apologies. Sheet 11 is also a duplicate of sheet 1. All we are doing is a cross join between sheet 1, into 2 times. And I'm just going to close that. And then I'm going to let it create an extract for us. Okay, so it does create, like it did create a relationship. So this is the ID from sheet 1, and this would be the ID from sheet 11. I'm just going to keep them side by side for the time being. And then how you see that for each ID, there are actually multiple records. So basically, now we can compute distance between this and this particular sheet 1 and sheet 11. Okay. To avoid small confusion, I'm going to write a small calculation which says determine origin and destination. Okay, if ID is not equal to, sorry, sheet 11, okay, ID in sheet 11, then we're going to call it as an origin. Else, I'm just going to call it as a destination. Okay, so I'm just going to drag and drop into this shelf. Okay, so interesting. So 2268 is my store ID, and then 2268 on the other data set. So I'm just calling it as an origin, and everything else is my destination. So now our task is to find the distance between this particular store and the remaining stores in the specific list. Okay, in order to do that, we have to do a couple of calculations before that. Okay. see how latitude and longitude is actually recognized there and not the same case with this. So I'm going to go ahead and change the data type to decimal. And then decimal. Okay. Longitude. So I'm going to call this as origin. Yeah, origin point. Okay, I'm going to show you a small thing just so that I don't create any confusion. So if I double click on latitude and longitude, I can see some points that are being plotted there. I can drag ID into there, and obviously this uses a little bit deeper into that. And alternatively, I don't really have to do that. I can just drag origin into the detail. It'll still show me the same information. So basically, what make point does is it actually creates a point for us instead of these individual columns. It is essentially the same thing, but except that it's been in a single calculation with a different data type. Okay, so now I've created one calculation for origin point. I'm going to go ahead and create another calculation for destination point. So I have to take latitude from sheet 11 and longitude also from sheet 11 so that I'm not giving it feeding a wrong information. So I can go ahead and double click on destination point. So these are my destinations. Okay, so how do you find distance between them? There's actually a formula in Tableau which says distance, and that will do the job for us. I'm going to select that. The syntax would be origin point, comma destination point, and then obviously I want it in kilometers, so I'm just going to give that. I'm going to call this as a distance calculation. Okay, I'm going to drag that here. Oh wow, I do see some values in. Okay, that's very good. You see how the distance between 2268 and 2268 is 0. That's exactly what you should be. It should be showing. The destination between within the two same stores should always be 0. And you can see even for the other stores from store A to B, C, D like that, you can clearly see the distance as well. And it does come in quite handy as well, especially when you're working in a retail environment or you're working on a different telco, I would say. Okay, so we have points and then we have distances. The next task that we are trying to achieve is to actually create a line. Okay, between 2 points. These sort of maps are actually called as origin and destination, or actually spider maps. So they're actually great when you're working with hubs, surrounding many points. So essentially, we're calling this as the source and this is as the destination. Usually, you use it pretty much when you're doing a flight routes such as Sydney to San Francisco, Sydney to Mumbai, Sydney to Gold Coast. Usually it's very visually easy for us to understand. What's the travel frequency between two ports or two destinations. Or alternatively, in retail environment, you can see how long do you have to travel with distribution centers, those sort of things. And fortunately, in some of the newer versions, to create these sort of maps are actually very easy. So I'm just going to demonstrate within the same example that I've shown to you previously. Okay, apologies for that. We were here. So our task is to now create a line between these 2 points. And we have a calculation for that as well. So there's a okay. So we have a calculation called make line, and then all it does is it'll create a line between those 2 points. So before I go in there, I'm gonna click on destination points and then origin points as well. Okay, destination points, and then I'm going to create a dual axis. Okay, origin point into the detail on one axis, the other one would be a destination point. For the time being, I'm going to change that, but the idea is for us to actually analyze some of the data there. Okay, origin is coming from sheet 1, so I'm going to drag ID into detail. Similarly for this, there's ID in sheet 11, and then I'm going to drag that into detail. Okay, and obviously I need to know whether, what is it? Okay. Okay, it is very important that I select a specific store so that it actually, that is being our origin, and the destination will be a set of different points. Okay, and obviously we need some slightly different way to represent that specific ID. So I'm gonna go ahead and then change the color for that. Okay, it's not the case with that. Okay, so that's where it is. I'm gonna color that to be red, and maybe I'll change the shape as well. Okay, I'm gonna change the shape to be like a star. And then is it possible to increase? Yeah. You see how that star is there? That's the origin. And we would like to plot between this origin and destination. Okay. So let's get back into the calculation that we are trying to achieve. Okay, apologies for that. Click edit, and then I'm going to say origin point, comma, destination point. And then I'm going to call it as create calculation. Okay, so I'm going to drag that into the detail shelf here, and then boom, there you go. It sort of exploded because there are too many things there. I'm going to eliminate some and then zoom it so that it's slightly easier and legitimate as well. Okay. Oh, there's actually too many, but that's okay. But the concept is, you have an origin and then you have a destination, and then this is how you actually create a line. We can certainly beautify this. I'll see if I can do that now. Okay. Should be lines. The second one should be actually a destination point and not the origin point. Okay, looks like I've taken a misstep. I'm going to go to my other window and then I'm going to check what I've done there. Okay, in one window I have a draw line, and the other one I have destination point. Okay, that's cool. Then I have a draw line, and then I'm going to take destination point, and then I'm going to go with sheet 11. Okay, I'm going to select the ID and then detail. Okay, there you go. You can obviously adjust the colors to be slightly different, and that's exactly what we call by an origin and destination chart, or essentially we can also call it as a spider chart. Okay. And it is very important that you understand the data and what sort of self join you're doing. It is very important. And that concludes my presentation. And thank you so much for hearing. And if you have any questions, feel free to add it to the chat window. And we have like 10 minutes now. Happy to take them in. Okay, so we have a question there from Thomas. So how does a buffer calculation differ from a distance calculation or radial select tool? Okay. Well, with buffer, you're actually creating a circle around a point. It typically works like distance, but you actually can't see that. So that's how buffer is actually different to a distance calculation. With distance calculation, you can actually see the number on top of your, let's say, from store A to store B. But with the buffer, all it does is it will just create a circle around it. Okay, it looks like we don't have any more questions. And thank you so much, team, for joining this presentation. If you further need any help with spatial concepts or visualization or predictive analytics, feel free to reach out to our team, and we'll definitely help.